for you now. Okay. Today, we will talk about data structures in Motoko. So I'm going to review the most common data structures, especially the one to begin with. What is a data structure? This is a place where you can store data and access data. And so the question that I always get is, which data structure should I use? There is not a good answer to that because it depends on what you want to do, how you want to store your data, and if you want to add data or how much data, how you want to access it, and all sorts of different considerations. So this is something that is actually beyond Motoko. In general, if you study computer science, you will notice that there is a whole range of theory about data structures, sorting algorithm, tree, and all sorts of complexity for different data structures. So I'm not going to go too deep into that today. I will mention a few things about each data structure, so array, buffer, list, and hash map. I will mention a few situations where they are good ideas to use and bad ideas to use, but I won't go too deep into the theory. So the first thing that I want to talk about is array. And how do we define an array? And actually in Motoko, there are two types of array. So array is a module from the base library that we've already seen. Well, we haven't seen it, but let me close that. But we've already seen the base library. So this is what I was talking about when we saw buffer. We also have a module for array. Array in Motoko are great when you want to store data, but you are not planning to add more data. Because an array in Motoko cannot grow in size. So if you decide to start an array, like for example, this one, let's say students, you store your students. So this is an array of size 4 here. We have 4 students. Then you cannot just add more students. If you want to add more students, you have to create a new array and reallocate all the students and add the new student at the end or the beginning, depending on how you want to do it. But essentially, you would have to create a new array. So you can quickly understand that, for example, if you have an application where you store number of users, it's not necessarily a good idea to use an array because every time you add a user, you will actually create a new array. And so this takes resources, computationally expensive. And this is not something that you want to necessarily do. But if you store some kind of data that is not growing, or at least when it's growing, it's doing it very rarely or sporadically, then you can use an array. Now, what is those two types of array? Just like we have immutable variable and mutable variable in Motoko, we also have immutable array and mutable array. So I'll start with the immutable array, which is the one that we use here. To define an array, you can use let or var, doesn't matter. It will matter regarding the variable, but it's not going to make the array immutable or mutable. So in this case, I've used var students. Then you have to specify, you have to at least think about what you want inside your array. So again, you cannot mix different elements of different types. We couldn't have like an array of text and inside I would have like a number. This wouldn't work, and Motoko would warn us that this is of type NAT and it's not expected type text. And then that's about it. Once you have your elements, you put them inside your array, you separate them with commas, and you can define your variable like this. So we can actually try. I have a very simple setup here, which is a function that returns my array. This project has already been prepared, and I have a simple dfx.json. So dfx.json, which is the configuration file for dfx, which lists all the canisters. And I just have this canister called data structure. The main file is the entry point for the Motoko compiler, which in our case is going to be main.motoko, this file. And the type of the canister is Motoko. It could also be Rust. So there are canister written in Rust. That would be Rust in that case, but for us today, it will be Motoko. Now I will run dfx start clean. So clean will enable me to destroy this .dfx folder. I don't want it because it's from previous deployments, and I want to start from, well, from clean environment. So I'm starting my replica. And so today, for the first time, I will not deploy on the playground. I just want to deploy locally. So I have my copy of the internet computer running locally, and I'm going to deploy on this replica. To do that, just run dfx deploy, the name of my canister, and no flags, so no playground, no network IC. And then it will automatically deploy on your replica. I don't know if you remember the talk I was doing on dfx yesterday about the wallet canister, but this is where it's actually appearing here. It's creating the wallet canister. So before we deploy our canister, it's actually creating the wallet canister to enables us to deploy the canister. Then it's creating our canister, and finally, well, we don't really need to care about that, at least for now. And we have access to the Candid UI. So of course, I have more methods. Just ignore the rest, all of those methods. We will see them later. And what we want to take a look at is get students. And we can see that we have our array. Quick note, this is the representation of an array in Candid. So the type that we see here, they are from the Candid representation. So what is Candid? Candid from the Candid UI, essentially canisters, and there will be a dedicated session on Candid where I will dive into it and explain it. But quickly for you to understand, canisters are written in different languages. So Motoko, Rust, even TypeScript, Python, C++, C++, yeah. Like many languages can actually compile to WebAssembly with a little tricks. But the problem is those languages, they have different representation for how to represent an array, how to represent a natural number, how to represent a text. And even if they all compile to WebAssembly, the code that is running is very different because of the memory layout and how types are represented and so on. And so Candid is this common interface that every canister has, so they are able to communicate one with another. For example, I could have an array and I can send my array to a Rust canister. And even if my canister is written in Motoko, it will work because there is this translation, Candid translation layer. So every type in Motoko has an equivalent in Candid. And it's actually pretty easy, at least from the Motoko side, because Motoko and Candid were created and developed around the same time, and by around the same time and by the same people, or at least close people, team. And so Motoko has been, or at least Candid has been designed very close to Motoko. And so, for example, a text in Motoko is a text in Candid, like this. A nat in Motoko is a nat in Candid. So you see the pattern, right? It's a bool is a bool. It's really easy. There is just a difference in the capital letter or not. But there is one thing that is a little bit harder to, I would say, map. It's how do you map an array in Motoko? An array in Motoko is a vec in Candid. So the vec that you see here corresponds to an array in Motoko. And whenever you are using the Candid UI, this is the Candid types that you see here. This is also the case here. As you can see, this is text, but not the text in Motoko, the text in Candid. And also, if you use dfx, to call your canister, so dfx canister call, we will call data structures and get students. Here, it's also counted in the terminal, the types that you see. Okay, so that closes our little parenthesis on candid. Now, let's take a look at the mutable array. What's the difference between the mutable and the immutable array? The mutable array can be, so every element in the array can be modified. So if you're coming from other programming languages like JavaScript, Python, TypeScript even, you know that you can easily take an array and do like array index, so array like 0 or 1, and then change the value that is inside. This is something very common in most programming languages, and it's very useful. But in Motoko, you cannot do that with an immutable array. So here, if I try to do, let's say, students number 3, so that would be, an array is always indexed from 0, so it would be 0, 1, 2, 3, so it would be this one. This one. Let's say I want to change it to my name. It will throw an error because expected mutable assignment. So it's the same error that when we try to change the value of a let variable. If you remember, a let is an immutable variable, we cannot change it. And same here with the immutable array. Now you might wonder, but wait, there is a var here. Like I should be able to, change this variable. So the var means that you can reallocate the entire array, like we could do students. Let's say like this. This would work because we are actually reallocating the variable here, students, that we've defined as mutable, but not for every individual element. Now, in the case of a mutable array, we can actually do this change. So for example, if I see this array, and this is how you define a mutable array, you simply add the var keyword to the type, before the type of the elements inside the array, and then var, and then the elements. So you just need to specify the var for the first element, and then all the others are also going to be variables. This is because you cannot mix variable element and non-variable elements. So if you have an array, either all elements are variables, mutable, or they are immutable. And now you can see that I can create this function, change students, which I give an index, which is the index in the array, and a new name, and I can actually change a student directly by modifying the index. And I don't modify the entire array. And even if I were to do this, this function would still work. So let me show you how it's working, and so that you believe me that it's really working. Okay, so we have the get student mutable, which returns the student's mutable, and I will explain why we have this array.freeze in a few moments. Actually, I'm curious. Let's see. Why do you think here? So here I have this function which I'm trying to do the same thing as I did here. So giving the value of the array, like showing the value of the array. Why in this case do I have array.freeze and not just return students? Like it would be, the equivalent would be return students mutable. Why do I think I need this? I'm curious if anyone has an ID or an answer in the chat. Please let me know. Otherwise, I will explain it. But if you remember, it's related to something that we've seen yesterday. Yeah. So you remember that yesterday we've seen this concept of shared type and non-shareable type. So if I were to do this, and I could maybe show you, let's comment that out. And so I would return a variable array, and I would just do students mutable. Here, it's going to give me the same error that we had yesterday with the buffer, which is shared function as shared function as non-shared return type variable text is or contain non-shared type. We cannot share non-shareable types. So this example, I think, is even better than the buffer, because imagine that you can share this array to other canisters, and they receive this array and they are able to modify elements from your array. They can change the index and they can change the content of the array. Can you imagine how crazy it would be, and how basically some actions on your code, you would not even know what's happening because it would happen in other canisters or other users, and they would be able to modify your data structures. So this is why I think it makes sense that we cannot share mutable data structures. And we call that non-shareable types. So if you want to share if you still want to share the content because you want to look inside this array, what you can do is take a snapshot, convert the content of the array to an immutable one, and share that. And so to do that, you would do asynchronous text. So you would share an immutable array. And now let's go back to our array module, which starts to get useful. We have a freeze function, which we can find. Let's see, where is the freeze? Here, it's in the top. Freeze is a function that transforms a mutable array into an immutable array. So this is exactly what we need. We need to take, as I said, a snapshot of this array, and so return that snapshot. And so array.freeze, and then the array that we want to freeze. We can also specify the type. So those are generic types when we use those functions, because the array can be of any type. So this function freeze can work for an array of natural numbers, textual number, Boolean, characters, and so on. So sometimes we have to specify the type. For example, here, we are using this on an array that contains textual elements. So that's why we have this. In case you're wondering, that's why we have this X, which represents a generic type, meaning any type that could be used. So let's deploy. Actually, we have already deployed, I believe, but I forgot to save. So let's save and then deploy. I missed the meaning of shared. So yeah, that was before, I guess your question was before I re-explain it. If you still don't get it, so I can give a link to, where is this? I think it's, okay, this, I don't know if it will be super useful because it's a little complex. Essentially this page explains what I've just explained about shared type, but it's a little bit more like I don't know, but it's a little bit more complex to read because it's written by engineers from Definity. So if you are brave, you can read that. I mean, it's not so complex. It's just the way to explain it is more, I would say, academical, and so each actor in Motoko may use but may never directly share internal mutable state. So that's exactly what I was saying. You cannot share the mutable variables which corresponds to the mutable state that you have. And this is what we call shareable types. Some types can be shared, some types cannot be shared. Okay, let's see. So I have this open too many times. So I want to try my change student and then get students. So change student is here. Let's say I change the index number 0 and I replace it by my name. And now get students mutable, I should see my name. So yeah, as you can see, it works. I have my name and then the rest of the students. Let me see a few questions that we have. If I call the method from another canister, will I get a copy of the array or some kind of pointer to that array? No, you will get a copy of the array in that case. I mean, in those cases, you will receive the content of the array, but you don't have any reference to the variable, if that's clear. Yeah, thanks for sharing the link to the array doc. I'm guessing that each of these actors are running in shared memory space. So actually, no, each actor has its own private state and you cannot directly access the state of other canisters. So that's the example I was giving in the first day. There is a canister that stores a counter and there is another canister that, for whatever reason, needs the value of the counter. The only way for that canister on the right here to, well, on your left, to receive the value of the counter here is to send a message and to wait for the answer of the canister here. So you cannot like access the state of other canister and just look inside their memory. In reality, some canisters, if they are on the same subnet, they are running on the same machine. So they are sharing, I would say, a physical memory probably. But I think each of them are running in their own processes. And yeah, in any case, it would be incompatible with the model of the IC. So let's go back to our code. Now that you've seen the arrays, and there are a lot of more things that we could do with array, but I don't want to do this session only focus on array. If you are interested, there is a dedicated page of the Bootcamp resource that talks about array. And of course, if you look at the array module, you have a lot of functions. So some of functions that can be useful are array.sort, which enables you to sort the array based on a sorting function. So for example, if you have natural numbers, you could sort them by incrementing order. You have the map method, which is super useful. It's, let me see here. The map enables you to apply a function to every element inside the array. So for example, you could, if you have numbers, you could double each number in the array by just applying the double function to every element. And you have the filters and so on. So take a look at this library if you want. It's pretty useful if you're working with array. Now let's move to the second part of the lecture. So we've talked about array. We've talked about share types. So that's done. Okay, now let's talk about buffer. So we've already quite had time to talk about buffer yesterday. Buffer is a class. How do I know that it's a class? Well, it is actually explained in the buffer module. So a class is different. Array is not a class. If you follow the array module, it's not a class. Buffer is a class, which means that you have methods that you can call on it, and it's also make it a non-shareable type. any class is non-shareable by default because you have functions on it. So anyone would be able to call those functions if you were able to share them outside of the canister. And also, I would like to show you the GitHub of the base library, where you can actually look at how a class is implemented. That's something that could be useful one day. Maybe for today it's too much, but so this repository, Motoko base, is the repository of the base library. So this is actually where the code that we import, this one from the base, is located in this repository. And each module that we've seen, so array and buffer, and we will see also the list, which are here. We will see the hash map as well. They are located here. So let's take a look at buffer. And you can see, so this is how the code of the module is defined. Instead of starting by actor, it starts by module. So if you take a look here, we start with actor. Here we start with module, so it's a completely different type of file. And then we have this class, public class buffer, and all the functions are defined here. So you can actually take a look one day if you want. It's pretty interesting how they do it, but you don't have to. It's just if you need to, I'll share this link. Now to define a buffer, we have already seen how to do it. So we import the buffer library here, and we just do let students buffer is equal buffer.buffer. So the buffer class from the buffer module, whatever we want inside this buffer, so text, and then the initial capacity, which, as I've said, I like to start with 0. What is this line for? This line is useful to make your code a little bit lighter, I would say. You can do that here. So here I'm defining the type. I'm giving the types. I could remove that, but as I already said multiple times, I like to have the type of my variables. And so instead of having every time to do, okay, the type is buffer.buffer, if you do that, public type buffer is equal buffer.buffer, then every line after that, you can just have buffer without buffer.buffer. So it's just a little trick. And you can do that with many, many types, actually, many classes. But yeah, that's just a little detail. To get your buffers outside of your canister, as we've already seen, you can do buffer.toArray. So convert the buffer back to an array, and we can share that outside because an array is shareable. And to add students, we can simply use the add method on the buffer and just add the student like this. So I can also show you that, but yeah, it's gonna work. One quick thing, the buffer module is actually going through a lot of changes. So you might notice some problem, like for example, there is this deprecated toArray method. So there is a buffer.toArray like this. And there is another way to do it, which would be students buffer.toArray like this. But this one is deprecated. If you use it, it will work, but it's gonna throw you a warning. Field toArray is deprecated. Use static library function instead. This is because buffer is going through some reworking. And so at the moment, the recommended way is to use buffer.toArray. I know it's frustrating. Sometimes you will see those deprecated methods. Even in other modules, you have quite a few deprecated methods because Motoko base library is going through quite some reworking from the developers. And so it's like work in progress and it's not super clean. But don't worry if you have those deprecated messages. Just try to see if you can find a non-deprecated like alternative. And if you can't, then at least for the bootcamp, it's okay for the week of the bootcamp. If you want to go beyond after that, I really recommend to try to move away from those methods, of course. And there are a lot of alternatives that you could look into. What is the meaning of the T? in a buffer, yeah, so it's a generic type, as we said. So instead of doing public type buffer not is equal buffer dot not public type buffer text, because remember that our buffer can have any element, any type inside the buffer. You could even have a buffer that contains other buffer. That would be a little bit hard to manage, but that would be possible. So instead of importing the buffer type, so here I'm importing the type. Instead of importing the type for one specific element like nat or text, with the T, it's what's called as a generic type. And so it's like importing it for any type, basically. Okay, so let's go back to our canister. So get students buffer and add student buffer. Right now, if I get my students, it's empty. And if I add a student, it's a Ben. It's not here, it's here. Seems like something is wrong here because it didn't add my student. Oh, yeah, it was not in the correct method. It was not here. Okay, great. What is the difference between T and X? Oh, it's the same. Actually, we could use any letter. So we could use A, we could use B, we could use T, we could use whatever, as long as you are consistent. So like if you use A here, you have to also use A here. Okay, so that's it for buffer. We already had seen it yesterday, so that's a little bit shorter on buffer. List. Okay, list is an interesting one because it's a recursive type. So list is defined, as you will see. It's a functional and recursive type. So essentially a list is defined by another list. Actually, it's defined by a tuple. So it's defined by two elements, an optional tuple. And you have a list, let's say a list of natural number. It's going to be one natural number and then a link to the next list. And when you arrive at the end of your list, you're going to have the null value. And this is when you know that the list is over. So lists are not necessarily the data structure that I use the most. Lists are great if you just want to add element into it, but they are not so great if you want to get element inside of it. That's what is written here. So if you're looking to find element inside your array, you have to go through in general, you would have to go through all elements inside the array because you have to go through the first element. Then if it's not in the first, it's in the second list. So you look into the next list and so on. So essentially, yeah, if you just want to add elements easily, it's okay to use a list. If you need to regularly look inside of it, don't use a list. You have better data structures. The list type is, I guess, for me, was a little bit confusing to use it in the beginning, just because it's like functional and recursive. So what I mean by that is that to define a list, like to create a list, you have to use a function. So we've seen that, for example, here, we can just define an array like, we just do like the brackets and then we add our elements. It's pretty easy. Defining a list, we have to use the list.nil method. So here, there is a method that you have to use that creates an empty list. And then that's how you initialize your list. So students list is of type list and then textual element inside is equal list.nil. So creates an empty list. And that's how you define your list. This might be, if it's your first time using, functional data structures like this, it might be a little bit frightening or scary, but it's not that complex. We have the same trick here. So I use the same trick for the type list as I use buffer. Again, it's a generic type, and I could use T, I could use X here, or whatever elements. And that enables me to do this, so I can define this as a list of text. If I don't do that, you will notice that this throws an error, and I should do this. So it's just a little trick to make my life easier. And yeah, I will get this back. How do I add element inside the list, and how do I get my list printed? Well, great thing, let me show you this one first. Great thing is that the list is a shareable type. So if we want to get the list of students, we can just return the list. As you see here, I don't have any error, and we can return that directly outside the canister. To add an element, we simply use this list.push method, but we have to be careful because it's a little bit different. Let me see. List.push adds an element inside the list and returns the new list. So we actually have to store the list somewhere. And that's why I have this variable, like here, mutable variable, student list. I'm going to create a new list and store the list inside my variable. It's very different from the buffer. If you remember the buffer, we just do .add because it's a class. So we can just do .add and add element inside of it. With the list, we have to use the method and then store the variable in our new variable. Store the value in our new variable, sorry. So let's deploy again. Let's see if I can get my list. So right now my list is null. Maybe something I didn't explain too much is this optional element here, the optional type. The optional type is very important in Motoko. The optional type enables us to specify when an element, we don't know if it's gonna be there or not. So what I mean by that is that any type can be defined optional, like for example, any type as an optional variant. So for example, you have text, you also have optional text. You have NAT, you also have optional NAT. You have Boolean, you also have optional Boolean. An optional type is either this type, so either you have a Boolean or you have the null value. So the null value is this value, and in Motoko, it represents the absence of value. When there is nothing to show, you return null. And so an optional Boolean is either a Boolean or a null value. An optional NAT is either a NAT or the null value, and so on. And so here, the list is an optional type. So the list is either null or this tuple. And so remember, when the list is over, you will see null at the end. In our case, we don't even have any element here. Like our list is empty, there is nothing. So it's actually returning the null value here. Now, if I add an element, with the add student list here, let's say Ben again. So as you can see, optional record, I have my element, and then I have my new list here, which the next list is actually null because I only have one element. And that's it for the list. So we are going quite quickly. Of course, you can rewatch this video, and you can also take a look at the list module and the documentation that you have in the Motoko Bootcamp repository. Honestly, I haven't used list that much in my years with Motoko. Not because it's complex, but just because, I mean, usually either you would use the array or you would use the buffer. I guess list would be, yeah, there are cases where you want to use list, but they are not that common. Finally, hash map. This one is super important. I've used more hash map than other data structures. Now it's changing because there are new data structures that are coming up, especially from the community, but I will talk about that later. But from the base library, hash map is really important to get. It enables you to create most of the data structures that you would be looking for. And I don't know how I deactivate this like animation. I need to take a look. Anyway, before we move into HashMap, so we still have 15 minutes. I think that should be enough. I'm going to see if we have some question. Okay, so I'm not sure I followed everything. Because there is not a push method in the... So there is not a push method in the base library. Oh, actually there is. Wait. Wait, I think I misunderstood the question. Why are we creating a new list? You mean here? Why am I creating a new list? It's just a placeholder, but you're right. Like we could totally do that. It's just wanted to. I think I just wanted to show that we are actually having a new list and then we are allocating it. So just to make things a little bit easier, but that also works, of course. Okay. Is there something similar to object or struct in Motoko? Yes, we can define object in Motoko, which I will dive into it more, especially today, because we are going to have a project where we define a new type that is an object. How to define an hash map and what is an hash map? So an hash map, again, this is not something like that is strictly related to Motoko. It's something more general. And if you are, sorry about that. If you are more curious about HashMap, I would recommend some links. If you want, I could send some links of videos that you could watch. But essentially, an HashMap enables you to link keys and values. So let me show you because it's explained in more details in this module. So you have keys, for example, let's say numbers, and you have values, for example, students. So you could have student number 1, student number 2, student number 3, student number 4, student number 5, number 6, and so on. And you can access those students through the key, which would be the numbers. So if you think about building like a social network or building a game or building some kind of data structure for your members, for your DAO, for example, the hash map is going to be super useful to store them. And it's also, I would say, a very average data structure. It's not perfect in terms of accessing and not perfect in terms of adding elements, but it's balanced. So it's average of most of them. So that's why you would want to use them most of the time. Now to define a hash map in Motoko, it's fairly simple. You just need to define the type of the key and the type of the value. So let's say the type of the key are natural number and the type of the value are text. So that's the type of your hash map. Notice that here we have a generic, but we have two generic type, key and v, which are the key and the values. I really need to find a way to remove that. Anyway. And then, so sorry, I'm coming back to it. So the hash map is a class, just like buffer. And to initialize a hash map, it's the same syntax as when we initialize a buffer. It was hash map buffer.buffer, and it's going to be hash map.hash map. And then you have 3 parameters that you need to give to the hash map. The first one is the initial capacity. Again, most of the time it's going to be 0. And then you need 2 functions, a function that takes your keys and returns a Boolean. So it's called the key equal function. It's actually a function that gives you an information, are the keys equal? So like if you have 2 natural number, are they equal? If you have 2 key, are they equal? And the second one is the key hash method, which is necessary to hash the keys. If you don't know why we need those functions, I guess you really need to watch a video about how a hash map is built and constructed, because it goes like it's functions that are necessary for the internal working of the hash map. It's not something that we need like us as developer, but that's something that the class behind the hash map needs to work. And so in our case, it's fairly simple because, well, a function that takes 2 natural number and returns an equality is going to be nat.equal. So nat.equal is nothing more than when we do like a test, an equality text. So nat module and then equal. It takes 2 number and it returns a Boolean. So if it's 1 and 1, it's going to return true. If it's 1 and 2, it's going to return false. Pretty simple. And then to hash a natural number, so a hash in Motoko there is also a module for hash. And a hash is just an alias for nat32. Okay, so that brings me to something I haven't talked about yet. You will notice that in Motoko, we have natural number 8, natural 16, 32, and 64. What's the difference between all of them? It's actually the memory representation for those numbers. So nat8 are going to be stored on 8 bits, 16 on 60 bits, 32 on 32 bits, and 64 on 64 bits. So essentially, when you have smaller numbers, you can use nat8, for example, but you cannot have a number that is above 2 to the power of 8 with a nat 2 to the power of 8 minus 1, I guess, on the nat8 library. And 16, it's going to be 2 to the power 16, 32, 64. So most of the time, we will always use the nat because nat is super easy to use. We don't have to worry about any limitation. It's actually a nat that can grow indefinitely. And the memory representation is also growing with the number. So it's actually pretty efficient. Even the developers of Motoko recommend to use nat in most of the cases. If you use nat8, nat16, nat32, nat64, it's going to be in very specific scenario that we might touch on, but most of the time you can use nat and not worry about that. But the one case where we cannot use nat is when we are talking about hash values. So hash values are packed into a nat32. So a hash is a nat32. And essentially what we need for our hash map here is a function that takes a natural number and returns a hash. And you can look here. There is a function called hash.hash, which takes a natural number and returns a hash. And that's exactly what we need. This function is deprecated, unfortunately. Again, another one. But it's totally fine to use in the bootcamp. You have my permission. Because it's actually deprecated because the hash is not very efficient when we grow to large numbers, but we are not going to grow to such large numbers in the bootcamp. Also, in Motoko, there is a huge need for more hash methods. This is something that is being worked on. And yeah, it's coming pretty soon, I guess. So if you have some issues with the hash, don't worry. Just use this hash.hash, even if it's deprecated. I don't mind, and it's not gonna break your code. As you can see, I'm using it here. And that's it. I have my hash map that is defined, and I'm gonna store my students, and each student is gonna have an ID. So you can see that I have a counter, which is student ID, which is going to count my students. And each student is going to have a location in the hash map associated with the key, which is this ID. So I will have student 0, student 1, student 2, and so on. How do we add students into a hash map and how do we get students inside a hash map? Let's take a look at the hash map library. Class hash map. Okay, so we've seen that. So we can do hashmap.size to get the number of values in the hash map. Hashmap.get starts to get interesting. Returns the value associated with the key if present and null otherwise. So let me show you how we could get. Well, actually, we already have this method. It's here. To get a specific student, I'm going to give the function an index. So let's say student 0, student 1, and then return the student through the get method. So student hashmap.get and then the index. This time I'm returning an optional text. So it corresponds to the name of the student if there is a student, but if there is not a student for this index, I have to return null. Well, I have to, at least the hash map is returning null because that's the way it works. I could also return something if I use a switch case. So I'm gonna modify this function just to show you that we can use something called a switch case in Motoko, which is super useful and you will use it a lot this afternoon. Switch case enables us to essentially divide our code into different blocks and run some code depending on the case we are located in. So there are two cases. The first one is that the students that we have is the null. So it's the null value and we don't actually have any students. Can return an error message. So no student found with this index. We need to, or we have a student. And so we can unwrap it. So here, when the student is returned, it's optional student, the type, but we can unwrap it with this syntax. So here, this is the optional student, but we only return the non-optional part. So you can see here, the type here is optional type. And here, the type is the text. So it's not optional. And now I can deploy that and show you. Okay, let's see. So if I use get student hashmap right now, you can probably guess that there is not any student because we haven't added anyone. So let's say with the index 0, no student found with this index. Okay, that makes sense. Now we have this function add student, which I'm not gonna write again, but just to show you what we do is that we do student hashmap.put and then student ID is equal student ID plus 1. So we increment the student ID. .put is a method that enables us to add element inside the hash map, and we just need to specify the key and the value. So this is where we are associating our value with a key. If I say student ID, so the student ID is going to be the ID of the student, and the name, it's going to associate those values. And so after that, I will be able to access it with the previous method. So if I use add students, I should say add student hash map would be much more clear, but yeah, let's do it. We could choose our index. It would be possible to have like two parameters here. So for example, we could have the name and then the index, but in my scenario, I'm not letting the user choose his index because it's automatically assigned by this variable. Just a personal choice that I made. So Once again, I don't have any students, but now if I add a student, so Ben, I'm not sure why I always select you, but you're my student for today. And now if I choose 0, I can see the name appearing. Of course, 1 is still gonna be empty, but if I add another student, then I'm going to find it. There are much more things that we can do with an hash map. We can replace element, we can delete element, we can remove element, and we can also iterate over the hash map. So this is something we will see this afternoon. Iterating means we can loop over the entire hash map. So we can, like, for example, we could return individually every student in the hash map, could transform students into an array, all sorts of things. And we can iterate over the keys, but also over the values and also over the entries, which is the tuple key and values. We can clone the hash map. We can do a map also on the hash map, map filter, and so on. So there are quite a few things. So this afternoon, we will actually build the project number 2. So here, which is about building bonds. So it's about what we've said, the DAO is a community. And so your mission is to make it possible for your students, for your DAO members to really become members of your DAO. So essentially registering into your DAO. And we are going to create a type member, a simple type in Motoko. So this is a custom type with a name and an age. This will represent your members. And you will implement the whole system, add member, get member, update member, get all members, and so on. So what we are going to build is basically the building block for any application that you can think of, because like having a profile for your users and being able to store data and get that data is the bare bone of any application. So that's what we are going to do this afternoon. And we will use the hash map. Okay, well, thanks for following up until here. All the questions that I haven't answered, we can answer it during the mentorship session. Take some time for break, or you can also start the project for this afternoon. I see everyone in a few hours. Goodbye.